Hello dear students, myself Amardeep Ramprasad Jadhav, working as Assistant Professor in Chemistry in Late Pushpadev Patel Arts and Science College, Resort. So today's topic of our lecture is BSc Third Year's Unit 4, Section B, that is drugs. Okay, so in this section we are going to see different type of drug molecules, what are drugs, what are ideal properties of the drugs and how they can be synthesized. Okay, so the molecules, every molecule, okay, like whatever molecule are synthesized in chemistry or present in chemistry, they all are not drugs, but some of the molecules which are present in chemistry are working as a drugs. Okay, so what are those properties that makes those compounds drugs, that can be seen under the topic drugs. Okay, now let's begin with the topic. In introduction, we are going to see the definition of the drug. Okay, so according to the definition, the substance which is used to prevent or cure disease in human being or animal is called as drug. Okay, any substance which has a property to cure any disease to human being or animal is called as drug, and not every chemical or every substance is called as drug, but some of these substances which are used to cure disease in human beings or animals are said to be drugs. Now, according to WHO, World Health Organization, there is another definition of the drugs. Okay, what WHO says: any substance used to modify or explore physiological systems or pathological states for the benefit of the recipient. What are physiological systems and pathological states? Like what happens in the body when some pathogen enters into the body, it produces some type of metabolites. Okay, after their digestion of some compounds, and those substances whatever produced after digestion of the molecules by the pathogens, they are these excretory products of these pathogens are causing the disease. Okay, so somehow these drugs modify these excretory products, and uh, the disease gets cured. Or in pathological states, what happens? The pathogen gets into the different phases of life cycle into the body. Like they are coming into the body, they are reproducing into the body, and they are increasing by the numbers and causing the disease to the recipient or the human being. In this case, what happens? These drug molecules, they attacks on some of the step in the life cycle of these pathogens, and causes its decrease. Okay, or causes to kill it. Okay, and this is how the pathological states were killed, and so that the pathogen didn't get increase in number, and that is how the disease gets cured. So the drug molecules are those compounds which modifies or explore the physiological system of the pathological states. Okay. Now, another definition given by WHO is synthetic or natural substances which are used to relieve discomfort and restore a state of well-being. Like what happens sometimes, we feel some discomfort in the body. Like we had some pain in the hands. Okay, pain headaches, pain in the stomach. So different molecules were used to relieve this discomfort of, this discomfort of pain in the hand, headache, and the pain in the stomach. So some molecules are used to relieve these discomforts and restore the well-being. Okay, restore the state of well-being. So this type of pills are also called as drugs. Okay, now what is called an ideal drug? Okay, so these are the properties of the ideal drugs as given below. One, it should be localized at the site where it is desired to act. Okay, understanding the point? What I said, suppose you are having headache, eh? And then this drug molecule should be localized to the headache portion only. Okay, it should not affect the hands, it should not affect the stomach, it should not affect the other parts of the body. So this is how the localization is said to be. If you are having discomfort somewhere in your leg, so this drug should be localized to these legs only. Okay, it should not affect any other part. So this is how the ideal drug should have been localized at the site where it is desired to act. Okay. Now next is it should act on system with efficiency and safely. Okay. Now if you are having pain in your legs, the drug should go there. It should relieve that pain and it should not give you any side effect. Okay. If it is not relieving pain and if you are taking to the drug, then that molecule won't say a drug. Okay. That molecule won't be working as a drug. It should be efficiently killing your. It should be efficient to kill your pain in your legs, and it should be safe. Okay. It should not cause other difficulties in the body, so other discomfort in your body. It should not be. Third point is it should not be toxic. It should not be toxic. So this is very simple. It should not be toxic. If it is toxic, it cannot be drug. If you are relieving your pain and it gets somewhere toxic to your body parts, then it shouldn't be drug. You are not going to take that drug. Okay, so it should not be toxic. Then fourth point is it should have minimum side effects. Okay, it should have minimum side effects. Like some side effects are like you feel some dizziness, discomfort, but like you are taking cough syrups. Okay, but if this cough syrup contains some compounds which makes you sleep. Okay, so these type of minimum side effects are okay. If the drug molecule contains this minimum side effect, then it is okay. It is said to be drug. Okay, but the drug should not be maximum. Like in some drugs, you may lose your memory, or you may having some hallucinations, different type of hallucinations for prolonged time. So such molecules shouldn't be taken as drug. Okay. Then fifth point is it should not damage host tissues or physiological processes. Okay. It should like in the definition of WHO they said physiological systems of the pathogens, not the recipient. Recipient means in this case recipient are human beings. Okay, suppose we are human beings, we are taking the drugs. So it should not damage our tissues and it should not damage our physiological process, but it should affect the physiological process of the pathogen. Okay, so this is how an ideal drug should have to be. Then the sixth point in ideal drug is cells should not get resistant to the drug after some time. Okay, so after some time, if you are taking some drugs continuously, then your body is automatically resistant to that. The drug won't show any effect on your body after some prolonged use. So it should not happen. If this is happening, then the drug shouldn't be called as ideal drug. Okay. Next, antipyretic and analgesics. What are antipyretics and analgesics? These are the types of the drugs. Antipyretics are the substances used to reduce fever. Okay, these substances which are used to reduce the body temperature are called as antipyretics. Okay, antipyretics are also analgesic. Analgesic means it relieves pain. Okay, like aspirin and paracetamol. So this is the structure of the paracetamol and this is the structure of the aspirin. Okay, Disprin name you must have gone through the Disprin name. Okay, very common. The Disprin tablet contains these aspirin molecule, right? No other analgesic. Analgesics are pain relieving. Likewise, here I have said analgesics are pain relieving substances. Okay, there are two types of these substances: narcotics and non-narcotics. Narcotics, drugs and all, right? This produces sleep and unconsciousness. Sleep means you feel sleep or you feel some unconsciousness, then such analgesic molecules comes under narcotics. And non-narcotics, this compound didn't cause any addiction. Okay, these type of narcotic compounds may cause addiction. Okay, so example of analgesic is phenylbutazone. Okay, this is the structure of the phenylbutazone, and this molecule is also called as butazolone. Now, phenylbutazone phenylbutazone. Okay, now how this phenylbutazone can be synthesized? Okay, analgesic phenylbutazone, diethyl malonate here, diethyl malonate when treated with C2H5ONA base in presence of C4H9Br, that is butyl bromide. Okay, this what happens? This C2H5ONA, this base abstract this acidic proton, and here this negative charge on this carbon then gets attack on this carbon and this bromine gets replaced. Okay, this is replacement reaction or the substitution reaction to get this dimethyl butyl malonate. Okay, here one of the hydrogen from this carbon is get reduced or get removed from this carbon, and here only one hydrogen and C4H9 group is there. Okay, then this diethyl butyl malonate, then reacted with diphenyl hydrogen. Okay, diphenyl C6H5 is phenyl, so diphenyl, two molecules are there, so diphenyl and hydrogen. When NH group is attached to NH, it is called as hydrogen. So diphenyl hydrogen. What happens? This nitrogen lone pair attacks on this carbonyl carbon, and this nitrogen lone pair attacks on this carbonyl carbon. Then this bond shifts over like this, and this C2H5 OH get removed. Okay, hydrogen from this and C2H5 OH. So this is how from this nitrogen over here and this nitrogen over here on this carbon. Okay, to get this phenyl butazolone or butazolidine. Okay, this is how this analgesic phenyl butazole is prepared. Okay. Now, what are the uses of this butazone? We have already seen it is used as an analgesic. Okay, with aspirin, the molecule which we have seen in here antibiotics. This aspirin and this phenylbutazone are used to cure rheumatoid arthritis. Arthritis is related to the this is related to the pain in the bones. Okay, arthritis, rheumatoid arthritis, and then it is also used in the treatment of ankylosing spondylitis, psoriatic arthritis, Ritter syndrome, arthritis associated with ulcerative colitis. So these are the name of some of the diseases where this phenylbutazone is used. Okay, go through this disease names and see what are the symptoms of these diseases. Okay, this is the homework part for you. Okay, this phenylbutazone is also used in the therapy of acute attack of gout. Okay, gout means what? Our intestinal part is called as gout, and when there is an attack in this thing, in this gout, when you get severe pain feeling in your stomach, then this molecule is used to treat this pain. Okay. What are the side effects of this phenylbutazone? Vomiting is there, nausea is there, fever is there, skin rashes is there. Nausea is something state like something you are going to get dizziness like thing. Okay, this is the nausea. And what we can say, you are not feeling well there. Okay, so unpleasant feeling. Now, it is toxic though has mild analgesic and antibiotic action, hence should not be used more than a week. Okay, this molecule is very toxic when we used it for more times. Okay, when we use it for continuous for more than a week, then this molecule may be act as toxin. Okay, so it should not be used more than 1 week. Okay, then next. Sulfur drug. This is another class of drugs. Okay, this contains sulfonamide group in it. SO2NH2 group. That is sulfonamide group. Like here we have said sulfonamide. Sulfonamide. Okay, sulfonamide. It is used to cure human bacterial infections. Okay, so this sulfur containing and amine containing group is used as antibacterial, plays important role in curing pneumonia, dysentery, like diseases. All these diseases are caused by bacteria like typhoid pneumonia. You know, sorry, what are the name of this pathogen? And then dysentery. Dysentery is caused by antiamoeba, another parasites. Okay, so these are the this is the drug acting over this pneumonia and dysentery. Then next example of this sulfur drugs is sulfanilamide, sulfanilamide, sulfaguanidine, sulfapyridine, sulfathiazole, sulfadiazine, etc. Okay. So now we are going to see sulfanilamide. So this is the structure of the sulfanilamide: para nitro sulfanilamide, para amino sulfanilamide. Okay. Then next is first this sulfanilamide was synthesized by Glumo in 1908 before birth of both of us, right? All of us. Now this drug is first synthesized by Glumo. How he synthesized this drug? He take this N para N acetyl sodium benzene sulfonate. Para N acetyl. This is at the para position of this sulfonate. So sodium sulfonate is there and it is attached to benzene. So N para acetyl benzene sulfonate. Okay? So this is how the compound is named. When it reacts with the another molecule of para ion acetyl sulfanyl chloride, okay, instead of this sodium, here it is chloride, and instead of this SO3, it is SO2, hence it is sulfanyl. Okay, and here it is sulfonate. In presence of NH4OH, ammonium hydroxide, at 40 to 50 degrees Celsius, it gives us para N acetyl sulfanyl amide. What happens over here? This Cl is replaced by NH4 here, and then this reacts with the water in presence of acid, gives us sulfanylamide plus acetone. Okay, now next, preparation of sulfanylamide by modern method. So the method previously we have studied is used by Globo in 1908. Now in modern days, this sulfanylamide drug is synthesized by the following way. What happens over here? Acetylenolide is reacted with chlorosulfuric acid in presence of ammonia to give us this para-N acetyl sulfanyl amide, which again then on hydrolysis gives us the sulfanyl amide. Hydrolysis means what? This what OH from this water attacks over this amidic carbonate, and this bond gets break between nitrogen and carbon to give us anidine over here. Okay, this is how this sulfanyl amide is synthesized in modern days. Okay, what are the uses of this sulfanilamide? It is used as antibacterial agent, used against cocci infection like gonococci, pneumococci, streptococci, etc. And again, it is the cheapest drug, but now replaced by its more effective derivatives. Okay, this is cheapest, but nowadays more of its effective derivatives were produced, like substitutions over here somewhere, and the drug is more effective than this sulfanilamide. Okay, now next part we are going to see in the next lectures. Thank you.